Atmospheric refraction. We've observed some natural phenomena in our daily life, such as the apparent random wavering or flickering of objects seen through a turbulent stream of hot air rising above a fire or a radiator. The twinkling of stars is a similar phenomenon. This wavering is thus an effect of atmospheric refraction, refraction of light by the Earth's atmosphere in our local environment. Let us discuss about them.
Night sky is very beautiful. It consists of different objects. Some of them are stars, while others are planets. Looking at the night sky, can you figure out if the object is star or a planet? Yes, you have been learning it from your childhood. The objects which twinkle are stars, and the objects that do not twinkle are planets. The question in today's discussion is, why do stars twinkle? Basically, the reason behind the twinkling of stars is atmospheric refraction. Let's learn how it happens. We live on planet Earth. The atmosphere of Earth consists of layers of air. The particles of air are closely spaced at the surface of the Earth than these at higher layers. That means the density of air is highest at the surface while it goes on decreasing towards the top layer. Now let's talk about a star. A star have its own light. Since they are at far distance from the Earth, therefore looks point-sized and so are treated as point source of light. The light coming from star, that is a starlight, when enters in the Earth's atmosphere, layer by layer, it experiences increasing density and so bend towards the normal at the boundaries between the layers. When it comes to us, we observe the star to be slightly higher than its actual position. Now air is fluid. It has property to flow. So, there are continuous and random variations in every layer of the atmosphere. These changes result in the random change in refractive indices of the layers. So, if refractive indices of these layers are not steady, how will the apparent position of star appear steady? The apparent position changes slightly but randomly. Similarly, because of random changes in refractive indices, the brightness of light coming from star also appears to be changing. The resulting effect of changing apparent position and changing brightness causes star to appear twinkling. Why do planets do not twinkle? The reason is simple. Planets are much closer to Earth. They reflect light falling on them towards us. Since planets are much closer to Earth, they could not be considered as point sources. Large number of rays coming from such objects undergo refraction in random manner. But while reaching at observer, They nullify each other's effect. That means neither the position of planet change nor there is change in brightness of light coming from them. The intensity of incoming light does not change. It remains constant, and so planets don't twinkle. I hope you have understood this concept very well. Thanks for watching this video.
Apparent position of Sun. Because of atmospheric refraction, we do not see the Sun or the stars in its true position except when it is directly overhead. As a ray of light from the Sun enters Earth's atmospheric at B, it continuously bends towards the radius of the Earth. The ray of light will reach the observer at O, as if it had come in the direction AO instead of in its true direction BO. Consequently, we do not see the true position of the Sun. It is due to atmospheric refraction that the Sun is visible before actual sunrise and after actual sunset. Do you know this fact? The Sun appears to rise 2 minutes before the actual rise, and it continues to be seen 2 minutes after it has actually set. Therefore, the day becomes longer by 4 minutes due to atmospheric refraction.